Earth is a water planet. The sun heats things up and water vapor evaporates into the atmosphere from Earth's land and oceans. Circulated by winds, this moisture flows around the world. Rainfall completes the water cycle and shows where the heat ends up. Most climate models assume that atmospheric moisture production and transport mainly responds to ocean temperatures and global wind circulation patterns, and less in a predictable way to land surfaces. But Earth is also the green planet. Seen from space, rainforests feel daily pulses of moisture into the Earth's atmosphere as they transpire during the day. These pulses of moisture, followed by rain, are clearly visible on this radar animated map of rainfall created by NASA. This water vapor either falls back locally or becomes transported by winds across large distances, bringing rainwater in downwind, often distant locations, even in another country. On this animation, the atmospheric moisture created over the Brazilian Amazon is transported to Argentina and into the Atlantic Ocean. So forests in one country can generate rainfall in another. Getting the global picture and being able to track rainfall from one place to another across the planet teaches us how forests influence the water cycle, how they help replenish our reservoirs, and how transboundary regulations may be required. The biotic pump theory provides a novel scientific basis for the huge streams of water vapor in the sky. According to the theory, forests are active low-pressure regions. They suck in moisture from the ocean for long distances into the interior of continents and sustain rainfall far within. Reliable rainfall in the interior of continents such as Africa and South America may therefore be dependent on maintaining relatively intact and continuous forest cover all the way from the coast. Regreening deserts may reactivate the pump, change wind patterns and bring rainfall into the desert interior. Equally, losing our forests could deactivate the pump and turn lush green continents into deserts. When we lose forests, transpiration declines. We might expect a weakening of rainfall in downwind locations and less rain at the interior of continents. This colourful view from a NASA climate model reveals the global impact of smoke from fires. The yellow mixture of organic and black carbon from fires spreads as haze across the planet. Black carbon, or soot, impacts air quality and human health, while black and organic carbon both contribute to climate change. Smoke-producing fires, such as peat burning over Indonesia and deforestation fires in the Amazon, further reduces rainfall, recent studies reveal. Drought triggers fire, but fire can further suppress rain by disrupting clouds convection. Understanding the role of forests and deforestation on local, regional and global precipitations is crucial. We know there's a link, but we do not understand it. The research is complex and in its infancy. The world needs to know these planetary works to manage better the world's reservoirs of fresh water, and how these reservoirs might become depleted without forests.